the agenda with you. Okay, so you can see my agenda.
Yeah.
Okay, it says Wednesday, 12/2/20. We will review quiz number 9. It was hard for most people, so I'll go over in some detail to try to, give you one more chance of understanding it. Hopefully, it'll help. We'll review any homework in chapter 7, lesson 1, 2, and 3, and this whole chapter is on geometry. Then we'll do the lecture, and it'll be lesson 4, 5, and 6 on perimeter and area, circles and volume. And then if we have any time left over, or we'll have time left over, we'll take a break, and then we'll go back and work on some of the homework problems in chapter 7. So that's the agenda. So first thing is to look at this quiz. Okay, wonderful quiz. Okay, so can you see my screen?
Yes.
Key at the top. The first problems were slope intercept form, trying to figure out, we're trying to come up with a linear equation that matches these conditions, this point and this slope. And I'm going to go to the whiteboard to go over it in some detail because I want you to get it right. Okay, so I'm going to share. Okay, so can you see my whiteboard?
Yes.
Okay, so number 1, we'll just do A. Okay. It has a point of -4 and -1 and -4. It also has a slope of 2. And we're to use this equation, y is equal to mx plus b. In this particular thing, what we're doing, we're solving for b by putting this information into this equation. Then we'll have the whole linear equation. So we want to solve for b. So what do? We have a y value and we have an x value. This, I'm going to annotate at this point. So let me do this here. So what I mean by that is this y, it becomes a -4. Okay, it's a -4 because it's -4 here. That's the point. That's one point. Now on the y-axis, the other point is -1 on the x-axis. So this x here is going to be -1. Okay, and we know what m is. M is 2. It's given. It's 2. Okay, so we have everything but b, and we're just solving for b. So we're just putting in this point for y is equal to -4, m is equal to 2, x is equal to -1, and we're solving for b. So with that, I'm going to go ahead and solve for b. And it looks like this. It looks like -4 is equal to m, which is 2 in this case. X in this case is -1, right? Plus b. And so now we have numbers in here. So now we can, the only unknown is b, right? So the next line would be -4 is equal to 2 times -1 is -2 plus b. Now we have to get b by itself. So we have to add 2 to both sides. So we have 0 on the right-hand side. So it becomes -4 plus 2 is equal to, I'm putting the details in here, -2 plus 2 plus b. Okay. By doing that, and I'm going to go back to annotating now. By doing that, these cancel out, right? This becomes 0, right? That's why we added 2 to both sides. The right-hand side is going to be -2, right? And we've got b over here. So b is equal to -2. Okay, that's all we're doing there. We're just solving for b. Okay. So when the dust settles, b is equal to -2. So now we can go back to this original equation up here and put our linear equation. We put it in terms of y is equal to 2x because that's the slope, and the intercept is -2. Okay. So that ends up being that's your answer. Does that make sense, Kathy and Rachel? You're muted, but where did Rachel, are you there? Oh, I have 4 participants now. Okay. Okay, I've got Kathy. Oh, Jessica's there. Okay, perfect. And Rachel's there. Okay. So questions on this. Kathy, does this make sense now? You see what I did?
Yeah.
Okay. And Rachel, does this make sense? All we're doing is we're just figuring out what B is so we can have this equation y is equal to 2m plus minus 2. If you looked at on a xy coordinate plane, it would look like this. It's going to draw it. That's supposed to be a straight line. So I did the wrong thing here, but it's okay. Where this is y and this is x, this minus 2, it means it crosses the y-axis at minus 2. So it's down here. So if this is minus 1, this is minus 2. So it crosses right here. It's also got a slope of 2 to 1. It's got a rise of 2 and a run of 1, okay? So another point would be right here. So now you've got 2 points. So this line will look like this. You can draw it through it. I don't really guess here, but like that. Oh, that's wrong. Sorry. It's got to be this one right here. So it's steeper. That would be the line that is represented by this equation. Okay? That makes sense? That's what we're doing here. You're given a point, you're given a slope, you're solving the linear equation. And I just drew it to show you what it looks like. Okay, that would be the next step. Okay, I'm not going to do B. It's exactly the same as this. Okay, I'll show it to you. It's on this key here. So here's A, 2x minus 2. That's just what I drew. B ends up being, again, you just plug the 4 in for y, the 0 in for x, solve for b. B is equal to 4, so therefore the equation is y is equal to 3x because 3 is the slope plus 4. Okay? That's how you do that. The next one, you're given the same information. You're just asked to use this formula to solve for it. That's all. That's the point slope form. So we'll do that. Okay? So I'm going to stop sharing that. Go over to share, and we'll go back to the whiteboard. And I wish I could scroll far enough. It just doesn't work that way. So I'm just gonna throw it, delete it, and start over again. Okay. So the second one, what you want to do is put down the form that you're doing. And I put it up there. It's y minus y1 equal to m, which is the slope, times x minus x1. Looks like that. You can see this is just a slope. This is like a form of where m is equal to y2 minus y minus y1, all divided by x2 minus x1. It's the same thing. It's just put in a different form. Right? Just instead of an x2, we have an x. That's the only difference. Okay. This is the same as this. If I were to put this, if I were to multiply both sides by x2 minus x1, I would have it over here and it would look just like this. Okay. But again, you're given the same thing. You're given a slope and you're given a point. Excuse me. On A, you're giving the point is 2 and 0. And the slope, m, is equal to minus 1/3. Okay, so that's what you're given. So again, we're just plugging things in, right? So let me highlight what we're plugging. Okay. So what we're doing is we're taking this 2, and since this is, or excuse me, 2, which is x, and we're going to put this right over here. We're going to take this 0, and we're going to put it right up there. We're going to take this m, and we're going to put it right, well, the 1/3 and put it right there, okay? So when you do that, then you get y minus y1, which is 0, is equal to m, which is minus 1/3, times x minus x1, which is 2. Okay, so now we have this. Now we have to do the math, right? So left-hand side, we've got y. Right-hand side, we've got 1/3 times, or minus 1/3 times x, so it's like this. Minus, now we've got a minus 1/3 times a minus 2. The minus and minus cancel out, so it's a plus, so it ends up be plus 2/3, right? So there's no negative here, so it's plus 2/3, okay? So we have that. At this point, we have it in the y is equal to mx plus b format, right? This one, the slope or the intercept is 2/3, the slope is this. So this is really your answer. Okay. Like that. I'm just looking at this thing here. No, I have this wrong. What? Just a minute. The 2 is the x. It is right. Okay. Anyway, that's how you do that one. Okay. Let me go on to the number 3. Stop sharing that. We'll go on to the next one. Okay, find the equation of a line that passes through 2 given points. This one, you're just given 2 points. You're not given the slope. So the first thing you have to do is figure out what the slope is. Then go ahead and use that slope in one of these points to solve for it. You know, I'll go through that in detail. I'll just do A, okay? So stop sharing. We'll go back to this. Share. Back to this. Get a new one here. Okay, so in this particular one, it looks like this. You've got 2 points. You've got a -3 and a 0. And the second point is you've got a -2 and a 4. So it looks like that. So the first thing we want to do is figure out what the slope is. And we said the slope is y2 minus y1 all divided by, right? Just like this. Divided by x2 minus x1 like that, right? So that's a, so we just have to fill in the blanks here, right? Substitute the points that they have over here. So in this particular case, make sure you understand what's the y1 and what's the y2. And so just to be redundant, I'm going to go over here. Okay. So this would be the y2, right? Y2, this would be the y1. This would be the x2, and this would be the x1, right? So knowing that, then we just go ahead and plug it into this formula. So I can't do anything with that. I've got to, just a minute here if I can do this. No, it didn't work. So let's do this again. So m is equal to, wait a minute. Huh, why did it, okay, I don't know. Okay, there we go. M is equal to y2. In this case, we said y2 was 4 minus y1, which is 0, right? That's all divided by x2. x2, we said, was minus 2 in this case. Right? Minus a minus 3, right? A minus 3. So it looks a little messy, but that's what we have, okay? So on the top, we've got 4 minus 0, which is 4. On the bottom, we've got minus 2. Minus, and this, it's a minus times a minus, which is a plus. So it's minus 2 plus 3, which is 1, right? So you end up getting m is equal to 4 over 1, which is equal to 4. Okay, so now we're halfway. Now we've got our slope, and we've got 2 points. We just need to use 1 point to solve for it. And I'll use the slope intercept form. I like that form better. I'm not sure why, but y is equal to mx plus b. Okay. So all we're doing now, we're going to plug in information so we can solve for b, and we can get the whole equation. Okay. So just take this first one right here. First one, y is equal to 0. So that's equal to m, we said, was 4. We figured it out. And x in this particular case is minus 3, right? And that's going to be plus b. And now we're just solving for b, right? So now we've got 0 is equal to minus 12 plus b. We have to add 12 to both sides so we can get b by itself. I'm going to flip it around, and so b ends up being equal to 12. Okay. So now I've got all my points. I mean, I've got my b, and I've got my m, and so now I can write the equation. So the equation ends up looking like this. Y is equal to 4x plus 12. Okay. Questions on that? You had to do 2 steps. You had to figure out what the slope is. Then you had to go ahead and put one of those points into this equation, solve for b, and then go back and write the whole equation. That's what I was asking you to do. Okay. Questions on that? But that's how you do these. Okay. It's just a couple little steps you got to go through. Okay, let's look at number 4. That number 4 stumped everybody. Well, I think maybe not everybody. Just a minute. I'll tell you in a minute. It did. Yeah, it stumped everybody. I can't believe it. Okay. I certainly wasn't trying to stump you, but it did. So we'll go over it in some detail here. Okay. Yeah, everyone got it.
That was funny, though, the way you said it.
Oh, sorry. Anyway, didn't think it would stump you, but it did. Anyway, here it is. Okay. A painter uses 15 gallons of paint to cover 300 square yards of wall or ceiling space. How many gallons of paint are needed to cover 1 square yard? Well, we want to put it in gallons per yard, right? We want the gallons to be on top. Now, some of you did it backwards, and that's how you got 20.
That's what I did.
You got 20, and Kathy did the same thing. So it's just, you weren't alone. So you got 20. So really, all you got to do is just look at the unit. When you do this stuff, look at the units. I'm going to share my screen with you just to emphasize it. It's all about the units, if you can understand that. And that's what most of this conversion stuff is all about. If you can figure out the units, you can figure out this stuff. So we said we have 15 gallons, right? And it covers 300 square yards, right? Something like that. Yards. And I just asked for how many gallons does it take to cover 1 yard, right? How many gallons does it take to cover 1 yard? So it's per 1 yard. So I want the answer in gallons per yard, right? That's what I'm looking for. Well, I know my number of gallons. I know my number of square yards. So it's just 15 gallons divided by 300 square yards. Right? It's really as simple as that.
Yeah.
That's being 1/20th or 0.05. Right? 0.05. gallons per yard. If you guys would have took care of your units, you would have realized that you got the
Yeah.
answer. You know what I mean? Because you would have had, well, it's yards per gallon. Well, that's not what he wanted. He didn't want yards per gallon. He wanted gallons per yard. So that's why it had to be like this, right? When you do any of these things, it's just what I call dimensional analysis. You're just taking care of all the units. Really, that's all you're doing, and making sure it's going to be the right way. That's all. And the more you do it, the easier it gets. But that's the key, is to look at those units. Make sure the units are correct. If the units aren't correct, then you're not doing it right. You have it upside down, or you're missing something. Okay. Okay. So that was a clean sweep on that one. So okay. But now you know. Okay.
Yes.
Okay. Number 5. What I want you to do there is just fill in this table, right, with a 0 in it, and where x is equal to 0 and x is equal to 2. With this equation here, y is equal to minus 2x plus 3. So you're just substituting 2 in for x, solving for what y is. And when you get, and then you've got 3 points. You've got a negative 2 and a 7, a 0 and a 3, a 2 and a negative 1. Plot those on this graph here, okay? And so negative 2 and 7, negative 2 is here, and a plus 7 is up. So that first point is right there. That second point is 0 and 3, which is right there. And the third point is 2 and negative 1, which is right there. Draw a straight line through it. This becomes the linear equation for y is equal to minus 2x plus 3. Do the same thing with this one over here. And you'll see when they cross right here. So the solution to these two equations is 0 and 3. That's where they cross. That's the solution. Okay. When we talk about systems of linear equations, that's what we're talking about. What is there a point on the coordinate plane that satisfies both of these equations? There's only one point here. It's when y is equal to, or x is equal to 0 and y is equal to 3. Okay, it's the only point. You may have two lines that are parallel to one another. They never do cross. They never do have a solution to a system of equations. There's no solution because they don't cross. Okay. So you either have it crossing or it's not crossing. If it's not crossing, it means they're parallel. Okay. But I just wanted to show you, I wanted you to understand how to, two things. One, how to develop a table, and how to graph it. Actually, 3 things. Graph it on a coordinate plane. And then 4, or number 3, determine what the solution is. And the solution is where they cross. Okay. That's what I was trying to show in that one. Okay. Number 6, in the function below, x is equal to 20, what's the value of y? And some of you made this complicated, and it's not complicated. I'm going to use my whiteboard here, okay? It's not meant to be complicated. Okay, so I'm sharing with you my whiteboard. I'm going to get rid of this paint stuff here. And so we're looking at number 6. So we have an equation. Yeah, we have the equation y is equal, excuse me, is equal to, and oh, here's where you really have to keep track of the order of operations. Okay, this is what messed people up in this one. Minus, x minus 8. So it looks like this, okay? Some people looked at this thing, they said, oh, well, this denominator here is 6 minus 8. And that's got them all screwed up. And it's not. It's this is one part of the equation minus this, because what you do is you take, first of all, you take care of everything that's within the bracket first, and then you divide by 6. Well, but the other part of this thing, of course, is we said y or x is equal to 21, right? So the first thing you want to do is substitute that 21 in there for x, okay? So that's the very first thing. So you can take this 21 and we're going to put it right in for there, right? That's the first thing you do. And I wish I could change my, I can change my color. Okay. So then the second thing is you say y is equal to 3 plus 21. What's 3 plus 21?
24.
24, okay. And it's 24. Get rid of this thing here, sorry. 24 divided by 6, okay? It's not 6 minus 8, it's just 6. Because this is one part of the equation. It's not that minus 8, right? Because remember what you do. You do everything in parentheses first, then you do multiplication and division, then you do addition and subtraction, and you go from left to right. So we did what's in parentheses first, we got 24. We don't have any multiplication, but we have division. So we have to divide this 6 into this numerator here. And then we'll do the addition. So so it looks like this, okay? And then below, then 24 divided by 6 is 4, right? Now we just do the subtraction, right? So it ends up being minus 4, right? But people got messed up there. Don't get messed up. You just remember the order of operations. That's really important. You do what's in parentheses, then you do exponents. We don't have any exponents here. Then you do multiplication, division, and you have division, and then you do adding and subtracting. You don't take the 6 minus 8 and make it minus 2. Okay? Does everyone understand that? You
What?
really, yeah, go ahead.
Well, so wouldn't the 3 plus x,
Mhm.
wouldn't that divided by 6, then shouldn't that be in the parentheses too?
Well, it is. I mean, it's understood. You're dividing this division bar is underneath the 3 and the x,
Oh, but it
right?
looks like
Well,
that
but see,
it
I got
division bar.
my brackets here, right?
Yeah,
It's, so
no, I
every,
understand that.
yeah,
Yeah, it doesn't look right that
well,
way.
okay.
Because,
I mean, sometimes you might see it like this: 3 plus x over 6 minus.
yeah, and then
That would have been clear, right? That's what you're saying?
yeah,
Well,
yeah.
sometimes it's just not given to you clear. It may be given to you like this, and you should be able to go from this to this. That's all I'm saying. Okay, by
No, no,
using the
it's
rule,
just
yeah, order of operations. I understand what you're saying though, Jessica.
okay.
I do understand, but you're going to be given things like this more so than like that. Okay, and they mean the same thing. That's my point. Okay, the point is you don't take the 6 minus 8 first. You don't resolve that, right? You don't simplify that part. You simplify this, and then you take this and add it to this -8. And you end up getting -4. Okay.
Weird. Yeah.
Okay. But that's what you do. Okay. So I'm going to stop sharing and we'll look at the last one.
That's weird.
Okay, the last one was just the domain and range of functions. And we talked about this somewhat anyway, but maybe not enough. The domain is any value on the x-axis, okay? So if I have a straight line, and this is supposed to be, this is a straight line, and the equation is y is equal to 2x plus 2, there's an infinite number of x values that satisfy this equation, right? Infinite number, right? Because it just goes to infinity. So the domain is negative infinity to positive infinity. It goes way over to the left, way over to the right, and keeps going, right? Because this is slanted, right? Same thing with the range is the y values. This range, this goes all the way down to negative infinity. It goes all the way up to positive infinity. So the domain and range are the same in this particular case. Okay, I just wanted to show you two different examples. The second one, this equation f of x is equal to 1/2 x squared plus 2. This is a parabola. This is a quadratic equation, right? Quadratic equations look like this. They have a vertex. They have a point that it doesn't exceed. Either it's on the top or on the bottom, depending on the sign of the x squared value, okay? This particular case is plus, so this vertex goes up like that. So the lowest point on the y is plus 2. In other words, if x is equal to 0, y is equal to 2. So it's right there. Okay. So the domain is all the x values. It's got every x value in the book, negative, infinity, all the way to positive. But the range, the lowest is plus 2, and then it goes all the way to infinity. Okay. Does that make sense?
Mhm.
You understand the function, you know, and understand what domain and range is. Okay. Means I can put in any value of x in here, and I'll get a value of y. Any value of x. I can't put any value of y in here. I can only put plus 2 all the way up because there's no values down here. This line, this curve does not go down, doesn't go below where y is equal to 2. So there's no, the range doesn't go down in that area. Okay, that's what that means. Okay, enough of that. Okay, now we're gonna go on to the what we're doing today. Okay, it's important to understand that domain, range, just understand how it works and you know what it does. Okay. Okay, so what about homework? Chapter 7, lesson 1, 2, and 3. Is there anything we want to look at? We don't have to, but when I teach these classes, usually I spend some time going over the homework, if you know, if you've done it. I want to make sure you understand it because it's really important in my classes because the quizzes are based on that homework stuff. So if you don't understand that, you're not going to do good in the quizzes. And if there's, yeah, go ahead.
Well, the issue I came across was there was like a lot of stuff to go over, but then
Okay.
when you went to the homework, there was only like 14 problems.
Okay.
And it just didn't seem like there was enough stuff to practice.
Really? Okay.
To learn. Well, yeah, I mean, there's 14
Yeah.
problems on there
Right.
compared to all of the info that
I understand.
and so it just seemed like there wasn't enough to I don't know what I'm trying to say.
Yeah,
Just
no,
like,
I understand. Yeah, it wasn't enough to
yeah,
practice
it's
with.
kind of hard to.
Yeah. Yeah, no, I understand. That's a good comment. I guess, yeah, the only answer to that is I could assign more problems, I guess. Well, there's not that many that were shown, really. That's part
Yeah,
of the problem.
yeah, and that's what I was saying. There was only
That's what you mean, isn't it?
14
Yeah.
problems.
Yeah.
The plane figures and then the
Yeah.
triangles. There was only 9.
I got you.
So that's why I don't have any questions on it. It's
Right. Okay.
Yeah.
Well, that's a good comment.
I
Yeah.
know there's nothing you could do about it, but that's
Yeah,
just
no, it's just yeah, I understand. The other thing too, in this class, we're doing, you think of all the subjects we've touched here. We're touching
absolutely.
a heck of a lot of subjects, and we're not spending
Yeah.
a lot of time in these things either. And so that's an issue. I know that. I'm not, you know, I don't have a defense for it. It's just the way.
Oh no, it's not on you either.
Yeah,
It's just
but it's just the way the course is. You know, it's
Yeah.
just
Yeah.
there's a lot of and we've gone through a lot of little comments. I mean, little what am I trying to say? Aspects of math in
Yeah.
here, a lot of them, and we're doing them very quickly. You know, we spend one day on quadratic equations. Well, you could spend a quarter on quadratic equations.
Yeah.
You know what I mean?
Yeah.
Really
Yeah.
understand all of it and factoring and everything else. And we're doing it
Yeah.
very, very quick. So
Yeah. So from now until the quiz, I'm just gonna go online and grab more.
that's good. Good for you.
and stuff.
Hey, you got to
Yeah.
sign up for that Math 66 class, though. You got to
Yes.
get that done. Keep bugging you
Yeah.
about that.
No, I will.
Yep, please do. Okay, I've got 7 students already signed up for it, so I'm looking for more. Okay, so I'm gonna, let's go on to the lecture then, okay? Okay, let's do that. Okay, here we are, lesson 4. Okay, so stop sharing. Lesson 4, boom, okay. So here we are, perimeter and area, okay? We're on page 394. All these little equations here, it'd be good for you to know these. I mean, they would usually be given, excuse me, when I give quizzes and everything, I usually give these equations. I would give them to you, but a perimeter is just the outside, the outside distance around a square, it's just, so a perimeter would be, where P is perimeter, would be 4 times one side, right? Because it's a square, each side is the same, so it's just 4 times S. A rectangle for the perimeter, you have a length and a width, so it's 2L plus 2W, okay? That would be a rectangle. A triangle, beside 1, 2, and 3, so it'd be A plus B plus C, okay? And they just give an example. Use the formula to find the perimeter of a rectangle. If you know what the length is, know what the width is. 2 times the length plus 2 times the width, right? Let me stop sharing and go to my board. So here you got a rectangle, boom. Okay, and say this, this is the width, and we're saying width is equal to 4 feet, and we're saying length is equal to 8 feet, right? And we said what the perimeter, and I guess we'll make it is equal to 2 length plus 2 width, right? So that's your formula. So just plugging in the values, right? So P is equal to 2 times 8, right? Plus 2 times 4. 16 plus 8, which is equal to 24. Okay. Okay, everybody see that and have it understand that?
Yeah.
It's all I'm doing, right? I'm plugging in for, I say the width is 4, the length is 8, boom, put it into this formula, solve for the perimeter. Okay, stop sharing. Not any harder than that. Okay, don't make it any harder. Okay, same thing with area. Okay, area is just equal to the, it's the side times the side. Well, the area of a square, it would just be one side squared, right? Because all sides are the equal. So it'd be one side by the other side. The rectangle would be the length times the width. Parallelogram would be a base times the height. This is a parallelogram down here. A base 12 and a height of 7. That would be the area of this. A triangle is 1/2 base times height. And a trapezoid, that's it's on the next page. The trapezoid doesn't look like that. It's got 2 parallel lines, but one is smaller than the other. And so it's the average of those two. That's why we have 1/2 times bases. Yeah, and so it's just the average. That's why you're doing it that way. I can show you that. So you understand on this one, of course, what's the area equal to? What's the area? Rectangle. What did we say? It was length times width, right? So it's just 8 times 24, right? Right, excuse me, 8 times 4, which is 32, right? And of course, it's square feet. Right? You could put feet, you could do it like this, however you're, they both mean the same thing, right? Put to the superpower of 2, I mean, it's superscript of 2, so foot squared. Okay, that would be the area. But if you had a, and I can't use my little things to do that. I'll just draw it. A trapezoid, that's what we talked about. It's like this. That's one side, and then you've got another side like this, right?
Oh, yeah.
Right, and then you got to deal like this, and you've got to deal like this. Okay, that's a trapezoid. It's got two lines that are parallel. Okay, so the area of this guy area is equal to 1/2 times times the height times base 1 plus base 2. It looks like that. So what this means is this would be base 1 up here. This would be B1, B2 would be down here, right? And the height would be this distance right here, right? From, I can do this. Be this distance from here to here, right? And that would be the height,
That would be height.
right? This would be the height. So now you've got all your parts. You got a B1, a B2, the height. And the reason we're doing this, it's B1 plus B2 divided by 2. So it's the average of this and this. So you're doing it like this so that really what you're doing is you're taking, I can draw it. You're taking the average of this one and this one. And it's probably like, I don't know. It's like that maybe, right? That would be the top one. That would be the bottom one.
Oh,
And
wow.
you got your same height, right? So it ends up being height times width, or in other words, it's almost like this. It's almost like a rectangle. That's why you have this formula. That's what that means. Okay. So B1 plus B2 is just an average. So it looks like this. And then so it'd be, this whole thing would be like this. It ends up being like it's a rectangle. That's what you're doing.
Oh, wow.
That makes sense?
Yeah.
That
That's cool.
and theoretically, this is equal to this, and this is equal to this, and that, I've done it correctly, but that's how you do it, and that's how you use that equation. Okay,
Nice.
so that's what that means. Okay, that's a trapezoid. The others are just, it's a rectangle, and the others are the parallelogram is just the base times the height. Okay, enough of that. Just so you hopefully understand it a little bit. That's what we're doing here. Okay. But again, you'd use these formulas, and if it was on a quiz, I would give you the formula. Okay, I would give you the formula. So you just have to know how to use them, right? Okay, I'm going on to the next page. Stop sharing. Yeah, I really want you guys to get this stuff. Okay, I mean,
Me too.
I want you to be successful. Okay,
Me
I
too.
want you to like math because math is good.
Awesome.
Kathy, I even want you to like math. Okay, it's a joke. Okay, Kathy, are you there? Okay. I want you to get it too. Okay. Okay. So here's the problems. Find the area and perimeter of each figure. This would just be the, this is like, this is a triangle. So it's 1/2 base times height. That's the area of a triangle. So in this particular case, the base is 13 and the height is 6, right? So it's 3 times 13. So it's 39 square units, whatever you're talking about. That would be the area of this whole thing. This is just a rectangle, so it's base times height, right? This one over here, you can treat this as a trapezoid. Well, that's what you would do. You would take 1/2 times the height, which is 22, times base 1 times plus base 2, and there's 14 plus 42. Add it together, take 1/2 times this, and you've got your answer. Okay, that's just a trapezoid. That's all it is. This is just a square. So it's just 4 squared. This one's just a parallelogram, so it's just base times height. And if you look at this thing, it's just like a rectangle, because you're adding this, but you're not adding this over here. So it becomes this whole length times this height. Okay, it's the same thing. Do you understand that or not? Does that make
Yeah.
sense? Okay, the rest of you understand that? Because on this one here, we're adding this triangle here. Or excuse me, we're not adding this triangle here, but you're adding it here. So one takes care of the other. So that's why you can say it's just base times height. It's just like a triangle. And this one over here is just, it's a parallelogram. So it's just, it's the base times the height. So you've got 4 times this height, okay? Okay.
Mhm.
Look at number 10. A square measures 6 centimeters on one side. What's the perimeter of the square in centimeters? What would that be?
4 times
6.
Okay,
Is that what it says?
yep, that would be the answer, yep. Because each side is just is 6, right? So it's got to be 24, right? Okay. Some of these others here, like number 9, I think you're trying to, it's a rectangle patio. The rest of the yard shows the measure of the diagram. What's the square footage of the grass? Yeah, the grass portion. So we want to measure this. So what you have to do is you got to get this total area and subtract the patio from it, and then you have the area. Don't do it any other way. Don't try to be fancy. Just take the area of the whole thing, subtract the area of the interior part, right? To get the other part. Don't worry about trying to figure out this part or this part because you don't have all that information. Okay. 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 Stop sharing. We'll go on to the next screen. Okay. Okay. So now we're on circles. Okay. Important thing to know about circles. A radius is from the middle of it to the outside, the shortest distance to the outside. That's the radius. The diameter is twice the radius. Okay. It's like slicing a circle in 2. Okay. Another big thing about the circle is the value of pi. So the circumference is equal to pi times the diameter, or pi is equal to the circumference over the diameter. It's that ratio. And this value is a irrational number. It keeps going and going and going.
forever.
Yeah,
Seems
forever. It just they have big computers that keep on trying to calculate this thing, and they're up to millions and millions of digits.
Really?
Yeah, it's
Wow.
crazy. I don't know why you would do that, but they do. It just keeps going. But I always just remember 3.14159, and then it just keeps going beyond that. But for your purposes, and most of it 3.14, or use your calculator. Take your calculator. If you got a calculator, and plug in bring up pi, what pi is. In other words, if you get your calculator, hit the second button. Oh, of course, my thing is dead now. Just a minute. No, it's not dead. Okay.
Where is it?
Yeah. Turn your calculator on, hit the pi button, and then hit enter. And you'll see a number. It should say like 3.141592654, right?
Mine just says pi when I do
Yeah, I
it.
know
That's
that, but bring that, but then hit enter.
where is it? Shift.
Or put pi and multiply it by 1 and hit
Oh,
enter.
okay.
Okay.
It just says that's weird.
Well, no, then
I don't
put in,
like it.
okay, put in pi, multiply it by 1 times 1, and then hit enter.
Sometimes, okay.
Okay, try that. What do you
Wow,
get?
wow, that's
Now it's a
weird.
big, it's a
I
big
use my
number,
phone.
right?
Yeah.
Well, anyway, my point
Yeah.
is that number keeps going and going, okay? When you're using it with your calculator, you're actually it's going out to at least, 8 or 10 digits.
There we go. Yeah, go on.
Okay. Or it's probably going out. It's going out to 2, 4, 6, 8. Yeah, it's 10 digits. That's what it's going out to.
Yeah. Yep.
Now, normally when we're doing these problems, you can just use 3.14 if you want, and you'll get a 2-digit answer with 2 digits to the right of the decimal place, right? And that's fine for what we're doing. Okay. Anyway, so just remember, circumference is equal to pi times d. Okay. Or pi is equal to circumference over diameter. Okay. And then the other equation to know is what the area of a circle is, and it's pi r squared. So again, you got to use pi, right? You can use pi r squared, or you can use pi r d squared over 4. It's the same thing.
I like pi squared.
Okay, I'm going to show you this. I'm going to show you. So back to my whiteboard. So we said, circumference is equal to pi d, right? I'm going to put in pi like that. Pi d. I guess we're are they using small d or capital D in that?
Small.
Small, thank you. Okay, so but area is equal to pi r squared, right? R, it's squared, right? Like that. Well, if I want to put d in this equation, it looks area is equal to pi times, I'm going to substitute. Now, we also know that we know that radius is equal to d over 2, right? We know that. So I'm going to substitute this d over 2 in here for radius. So I'm going to put d over 2, okay? And I'm going to multiply it by, I'm going to square it, okay? So it looks like that. So doing this whole thing, oops, sorry. I want to put it, I don't want to put it there. I want to put it down here. I have to do this again, sorry. So area is equal to pi times, I'm going to put this d over 2, and I'm going to square it, right? So it looks like this. Well, this is equal to pi times d squared, pi times d squared, all divided by 4. So you'll see this in some equations. You'll see it looks like that. It's the same thing. So if you have d, and if you're too lazy, you don't want to figure out what r is, you can put d squared divided by 4. It's the same thing as putting r in there, because
D
r
squared
is
divided by 4.
yeah, it divided by 4 because it's d over 2, and you're squaring the 2 also, so it becomes d squared over 4. So sometimes you'll see it like that. That's all I'm trying to say. It's the same. This is the same as this, right? Just so you know.
Yeah, I like the other one better.
Right? This is exactly the same as that, right? Only this one's using D and this one's using R. So you'll see equations like that. So don't be confused if sometimes they do this. It means exactly the same thing. Okay?
Okay.
Stop sharing that. Or is there anything else on here you want to see? Or are you good? Rachel, do you have this? And Kathy,
Yeah,
this is
working on writing it down. I took a screenshot of it.
Oh, okay, good. Good for you. Okay. Smart. Okay. Okay. And also you can find, I'm recording all this obviously, so it isn't a lecture, but you'd have to go through and find it. Anyway, so example 2, if the circular surface of a satellite component must be covered with heat resistant tiles. If you know what the radius is, what's the area in square meters? Well, you can use this equation. A is equal to pi r squared. put 3.14 for pi, 4 for the radius, square it, you get 50.24 square meters. The other thing to note is if I used a 3.14 here, I only want to put this out 2 digits. I don't want to go any more because I don't know what the accuracy is beyond that. Because I'm not putting 3.14159. I'm just using 3.14. So your answer is just, this is the accuracy of the answer. Okay, it's just 2 digits.
So just use how far they.
Yeah,
that
and how
inch
far
is.
that you get, exactly, whatever you're given in your problem, that's as far as you use. You don't go any further. That's the rule, okay? Because it's inaccurate outside that. And they're just showing you what the radius is. Okay, I'm going to go on to the next page.
Decimal.
Just a sec here. Okay, stop sharing. Sharing. Okay, here's the next page. Example 3. What's the circumference of circle B if to the nearest centimeter? The radius of the circle is 5 centimeters, therefore the diameter is 10 centimeters. Okay. And finding the circumference, put in that 10 centimeters here, times 3.14, you get 31.4. You could say 31.40 if you wanted to, but I don't know. It's fine. Either one I think is probably good. Okay. These practice problems, find the circumference and area. Just remember what the formula is. Circumference is equal to pi d, right? Or pi 2r. It's the same thing as d. And here you're given what r is, so you're going to use r. You're going to use r, or, you know. And area is pi r squared. You should be able to figure out what the area and circumference of all these circles are. Okay. Let's just do number 3. Okay. So stop sharing. Do number 3. Get rid of this. Okay. So remember our 2 formulas. Circumference is equal to pi d or pi 2r, right? Same thing, right?
Yeah.
And the area A is equal to pi r squared, right? Which is equal to pi times d squared all over 4. That's the same thing also. So if you're given r is equal to 4, let's say centimeters, what's the circumference? You're going to plug that 4 into this. And we're saying, and then here's the other part of it. We're saying pi is equal to 3.14, right? So then you just plug it into that formula, that equation there. So C is equal to 3.14 times 2 times 4, right? 4 centimeters. It looks like that. So you multiply that out, you get the answer. That's what C would be. A area is equal to pi r squared, so it's 3.14 times we're back here. Yeah, I did that right. Okay. Here we're just gonna use r. Would be 4 times 4, right? So 16 times that, and that would give you the area. Okay, so you using these equations. Questions on that? Okay, so I'm going to stop sharing and go on and look at the ones in the bottom if there's anything interesting. Okay, what about these? Anyone that interesting to you? Okay, Okay, what about number 5? So you've got a fountain here, okay? We can see the fountain. The diameter is 12. Okay, here's the fountain. This is the plan view of it. This is an elevation. You're looking at it. Which of the following expressions would be used to find the area of the bottom surface of the fountain? What would that be?
Wouldn't that be the C equals pi times D? Or is
No,
that not
No,
right
no,
one?
no, I want the area,
Area?
right? Because we're talking about the area. Find the area of the
Oh,
bottom.
R squared.
So it's pi r squared, right? So which one
Mhm.
would that be?
That would be pi r 12. Let me use my calculator.
What would you do in that one?
I gotta get my calculator up.
Well, but first of all, look at the, what are you gonna plug in? What,
Where is
what did we say the area was equal to? Pi r squared, or it's
R squared?
d squared over 4.
Yeah,
So
that's it.
So
Over
look
4.
down here. So which one, but the point is, look down here, which one would be correct? What would that be?
Gonna be A.
Nope, not A.
B.
It's B, right? And so let me show you that. So it's like this. Yeah, not A.
Because it's gotta be this.
So we said area is equal to 3.14 times r squared, right? That was one of the values, right? In this particular case, we know what D is, so we know what R is. So R is 1/2 D, right?
Oh, yeah.
Right?
R.
So you look at that, and the second one said it's 3.14 times 6 squared, right? It was like that. That's your answer right there. Right? Because it didn't give that's what B was. It didn't give a D over 4 or D squared over 4. So this is what they were looking for. So it's B. B is the answer. Okay. You got to understand what the area is, and whether you're given diameter or radius, and you can convert one to the other. Right. That's what that problem was. Okay. And I think we'll go on to the next one. Yeah. Let's just go on to the next page. Okay. Stop sharing that. We'll go on to the next page. Okay, now we're in lesson 6. Sharing that. Lesson 6. Okay, volume. Okay, these formulas. Again, I wouldn't expect you to memorize these, but know how to use them in a problem. Okay. Rectangular prism. Okay. Rectangular prism is just a block. Okay. You have a base and you have a height. So they're saying the volume is equal to, when they put a capital B here, they mean it's the area of the base. It's the area of the base times the height. That's how you get cubes. Okay. A cube is just each edge cubed, right? Because if a cube is 1 by 1 by 1, so it's 1 times 1 times 1, or 2 by 2 by 2, and that's why they show volume is equal to the excuse me, the edge cubed. Okay. A cylinder is just the volume. It's just a circle with depth to it, right? Well, it's the area of that circle times the height. So that's why they have pi r squared times h. Pi r squared times h. That would be the volume of a cylinder. A sphere is a thing that with a pointy part of it, but it's got a circle on the volume, on the base. Anyway, yeah, I can't really develop this, but it's 4/3 times pi r cubed. That's the area. So just know how to. I mean, if you're given a problem like that, you'll be given what that formula is. Here's a way of looking at, there's a cardboard box as dimensions 4 by 5 by 3. So here we're figuring out what the base is. The base would be the bottom, 4 times 5, and then multiply it by the height, right? That's how they get 60 cubic feet. And this one little blocks here, each side is the same, so that's where they get the edges. If each edge or each side is 2, then the cube's going to be 8. Right? That makes sense?
Yeah, kind of.
Okay. Okay. The cylinder has 2 circular bases, you know, one on the top, one on the bottom, like cans, barrels, tanks, so forth. Right? They're all cylinders, right? So let's look at some of the problems here. Okay. Again, we're doing geometry pretty darn quick. I know that. But the way it works. Okay, here we go. Okay, so example 3, a storage tank has a radius of 1.5 meters and a height of 3 meters. What's the volume of the tank? Okay, it's base times height, in other words, pi r squared. That would be the base of this cylinder. So you know the radius is 1.5, so it's 3.14 times 1.5 squared. And then it's times the height 3, and that's how they get 21 cubic. And they just rounded it. Yeah, I don't know why they rounded it, but they did. 21 cubic meters, okay. And these ones down here, this is just a rectangular prism, right? You can figure out what the base is. 5 times 8 is 40, times 4 would be 160. So it'd be 160 cubic units, whatever the unit is, right? Unit cubed. This is just a tank. So you get the area of the base of the tank, which is pi r squared. It gives you 6 for the diameter. Well, I'd convert that to 3, make it 3. So it's pi r 3.143 squared times, and then the height is 5. Okay. This is just a cube, so it's 1.5 cubed. There's another cube, right? Each side is 3, so it's 3 cubed. Here's another rectangular prism. So the base would be 7 times 6, which would be 42. The height would be 10, so it would be 420 cubic units, right? Right? And then this would be another cylinder. This is just like this one up here, same as that one. It's just on a different axis, right? So you figure out what the area of the base is. That's the top part or the bottom part. Doesn't matter. It's the same thing. Pi r squared, you've got what r is, 5. Plug it in, multiply it by 3, and you get the volume. Okay. So I know I've gone through these really fast, so let's do 1 or 2 here. Okay. We're gonna look at okay, we're gonna go here. And we're gonna get another page. Okay. So just remember that if it's a cylinder, area is equal to pi r squared, right? Times the height, right? So if you have a cylinder, and I can't draw it. No, I can't. There's nothing here to help me. I can't even believe there's not even a cylinder, not even a circle, nothing, not even a circle on it. Well, okay, yeah, I guess you do it like that, yeah. So you've got a circle like that. If I could.
Yeah.
Well, you know what I'm trying to do. I'm just, now I can't forget that. So, but anyway, you understand what a cylinder looks like. You know, it'd be like that. Oh, that's not very good. Forget that thing. You know what it's like a beer can. Okay, you got a beer can. Okay, and you know that beer can. You know what the radius is. Say the radius is radius is 1.5 inches, 1.5 inches. And you know the height is equal to 6 inches. What's the volume of that can? Okay. What do you use this? So, oh, this shouldn't say A up here. It should say volume. It should say V. Sorry.
That makes sense.
Yeah, don't, ugh. I can't get rid of that thing other than, just a sec here. Get rid of this, but I don't think I can put a V there. For me, I'll try just a minute. I put a V there. Oh, there we go. Okay, so that's the volume. Okay, so now the volume is equal to pi 3.14 times 1.5 times 1.5. That's 1.5 squared times the height is 6. Okay, and that's going to give you the volume. And what's the units of this going to be in? What would be the units?
Inches?
Not
Is that what you
inches.
said it was?
No, I don't want
Oh.
inches. I want cubic inches.
Oh.
Right? You got to say cubic inches, right?
Gotcha.
Because you've got 3 different dimensions. You've got three units here with inches in it. So it's and whatever it is, let's say it's 2, 12, 12, 3, say it's 36 or 37 cubic inches. I don't know. Something like that. It would look like that, cubic inches. Okay. Or you could write it out. That would be if this was the answer. That's how you would do that. Okay. So that's the volume, and the other ones where you would have, you know, you had
40,
is it 40? Okay, I believe it.
42.39, I think is what
Okay, I just estimated. So it would
Yeah.
be that cubic inches. But if you had a rectangular prism, that's sort of what I'm trying to draw here. Okay,
prism.
right, like that. The base is like this, right? I don't know if I can let me do this. Yeah, like that. Okay, and then the other one's right down there. Okay, so that's a rectangular prism. And the volume of that is the base times the height. The base is this bottom part or this top part, right?
Yeah.
That makes sense?
Yeah.
So if you had, let me just go here like this. So in this one, let's say this was 3 feet and this was 3 feet and this was 10 feet, right? You get the area, you get the base. So I said volume is equal to base times height, right? Base is 3 times 3, right? And the height is 10. So this whole thing is equal to 90. And if I said it was feet, it would be 90 cubic feet, right? That's how you would do that, right? You'd figure out what the base for rectangular prisms, okay? That's what that is. Know what the base is. Or you could take 10 times 3 times 3. It's the same thing, right?
Yeah.
But in this particular case, a lot of these problems, you'll be given the area of the base. They'll say area of the base, and that's how they do it. Even in some of these cylinders, they might say, well, they'll give you the area of the base. So it's just the base times the height. Okay? It's the same formula, right? You see that?
Yeah.
If you're given the area of that base, you don't have to worry about pi r squared. You just need that value times the height. Okay. Questions on that? That's how you do that. Okay. I'm sharing that. See if there's anything else on here on this page. Okay, what about number 7? A rectangular box with a volume of 80 cubic feet has the length and width shown on the drawing. It's right here. What's the height of the box? How would you determine that?
I don't know now.
Well, okay. Well, see what are we given? We're given the base, right?
Mhm.
4 by 4, that's the base of this box.
Okay.
So that's equal to 16 square feet, right? Or whatever it is, yeah.
Yeah.
And so, and you're given what the volume is. So you know the volume is equal to the height times the base. You're just solving for the height.
Hmm.
Right? So I'll go to my board here and we'll do it. Okay. So it's 4 by 4. Okay, I got it. So here's how you do that problem. Start over here. Okay, so we know that the volume of a box or a prism, whatever, rectangular prism, is equal to the base times the height, right? That's one.
Mhm.
One way of doing it. If we know what that base is, and so I'm just going to draw that base. So I'm going to draw this thing. Lord, oh, this isn't good either. This is not good. Sorry, this is not.
Oh,
That looks terrible. Oops. I went one too many, and I can't go back. Great, jeez. Volume is equal to. Just a minute. Is
base
equal
times height.
to base times height. Let's
Base times
do
height.
this again here. Let's try something else. So if we have that's the base, and then we have another one. I don't know if I can do one over it like that. I can.
Hmm.
I don't know if this helps or not. I don't know. No, this is not. Yeah, no, this is not good. Maybe, yeah, okay.
Oh, look at that.
Yeah, there we go. I knew we could figure it out.
Wow.
Yeah, there you go. So we got that. So what you're given in this, you're given the base, right? And the
Mhm.
base in this, and that base was 4 by 4. So I'm going to
Yep.
plug in numbers. The base is 4 feet. 4 feet. That's supposed to be a foot. And this is, so pretend that these are the same length, okay? 4 feet like that, okay? And you're given what the volume you're given what the volume is 80, right?
80. Yeah.
It's-
Oh, so then you just solve for H.
exactly. You just solve for H. So H on this equation up here, H is equal to base, or excuse me, is equal to volume divided by base. That makes sense?
Yeah.
I'm just solving for H up here. So I'm going to divide both sides by B. So I got V over B over here. V over B.
Where did
So
you get the 80 though?
because that's in the problem. They give you, they say the volume is equal to 80,
Oh, okay. Oh, okay.
right? And then you're just solving for this H. You want to know what is that H, right? That's what you don't know. That's what you're solving for. So now you've got H is equal to 80 in his cubic feet. And here's where the dimensions come in handy. Put them in there so you know what it is. Divided by 16 square feet, right? So you know when you divide the square feet into the cubic feet, you're going to get feet, and that's what you want. So you know you've done the right thing as far as that. How many times? What's 80 divided by 16? It's a nice even number.
16 is 5.
5, right? So it's 5 feet. That's your answer. That makes sense?
Yeah.
Okay, so if you're, like I say, if you're well, you're given everything but one element. You're given the volume, you're given the base, you can solve for the height. That's what you're doing.
Got it.
Okay?
Hmm.
That's all
Nice.
that is. Okay?
Yep.
So I'm going to stop sharing that. And we'll go on to the next page, the next part. Okay, one more little lesson to go here. Okay, I realize it's a lot of stuff. I can't. Okay, volume of pyramids and cones. Okay. Don't worry about memorizing the formula, but know how to use the formula, right?
Alright.
Okay, you've got a pyramid here, right? It's the base is 4 by 4. That's the base. The volume of that pyramid is 1/3 times the base times the height. So you have to know the height from that base all the way to the tip, the vertex of that pyramid, right?
Hmm.
You know that, you can go ahead and solve for it. So it's just going to be 4 times 4 times the height divided by 3 because it's 1/3. This is the formula, 1/3 base times height. That's why the base becomes an important thing in a lot of these formulas. Capital B, not little b, but capital B. It's the area of the bottom of the thing, right? That's what the base is.
What's the what would a little be?
A little b would just be a side.
Oh, okay.
Yeah,
I-
that's a good question. It would be a one dimension, but the big B is 2 dimensions. It's got it's units squared. That's what I mean by 2 dimensions.
Oh, okay.
Okay. So that's for a square pyramid. When they say square pyramid, that's what they mean. The base is a square, right? It's 4 by
okay.
4. That's a
Oh.
square pyramid. Okay. And that's just what we did here. 1/3 times 5, 5 squared. Well, I'm looking at this one. I'm sorry. Yeah, it's the same idea, but it's a 5 by 5, and then the height is 6, so it's 5 by 5 by 6. So it's 1/3 times base times height. Okay. Okay. Now a cone. Here's the other thing to know. A cone is similar to a cylinder. It's got the base. It has one base that's a circle, right? That's a cone, and then it all leads up to a vertex. In other words, a height from that cone. Here's the formula for the cone. It's 1/3 times pi r squared, because pi r squared is the area, right? It's the same formula as a triangle or as a pyramid. It's exactly the same thing, except the base is given. It's the base of the area of the circle, as opposed to the base of a square up here. You see that? That's the only difference in that formula. It's 1/3 pi r squared, or it's 1/3 base times height. 1/3 pi r squared h, or base times 1/3 pi, 1/3 base times height. Okay. Does that make sense? Well, let's look at a couple problems and I'll do it on the whiteboard for you. And really it doesn't get any harder than that in this stuff anyway. So I'm going to go here, boom. Okay, here we go. So this is a square pyramid, right? It's got a square and it's a pyramid. So how do we find the area of that guy? I'm gonna write down these numbers. I don't remember.
Third
Yep.
times base and height.
Yep. I'm going to do that. Base times the height, and it looks like this. Okay. So 1/3 base. So number 1. So it's going to, and it's 3 by 3. Oh, that makes it easy. Okay. So stop sharing that. I don't think I can draw this thing very good. Okay. So you've got this. Got a base like that, and it all goes up to a. Yeah. See, this is hard to do this.
Where?
You know what I mean?
Yeah.
Right. It looks like that, right? This is a square pyramid. Okay, the base is square, and we said the volume is equal to. Do that is equal to 1/3 times big B times h by little h, right? That's the formula. So in this one, B is equal to 1/3 times, and we said each side of this is 3.
3.
So it's 3 times 3 is the base part of it. And then the height is also 3 in that particular problem. So it's 3 cubed divided by 3. So that whole thing is just 9. Because one of these 3's cancel, that's out, and you've got 2 more 3's left. You end up with 9. If it's feet, it's cubic feet, or whatever the unit is, it's cubed, right? This would be the base. This would be the volume of this square pyramid. Okay. Questions on that? Again, it's all, you just got to know that that's the formula, right? That's what you have to know, right? And this ends up being the answer. Okay. Okay, that's that one. So let me stop sharing. Let's do one more. Okay. Let's do a cone. Let's do number 2. Okay. So it's 6 and 9. 9 being, okay, so stop sharing that. And share, go here. So I'm going to just go right here and put it over here. Whoops, it's supposed to be a circle, sorry. And that, and this thing all goes up to a point.
Times radius.
Right. So it looks like this, right? And what is the height in this one? Somebody tell me what that height is.
12 centimeters.
12?
Which one are we doing? Oh, I was doing the wrong one. Never mind.
Okay.
Looks like 6.
6.
It's 6? Okay. And what's the radius? Radius of that one, what, 3? Is that what it was? I don't know. I lost it. I mean, I don't
Which
know.
number are we doing? Number 2 or number 3?
Let me go back and look. I don't know. I have to look at it. Just a minute. Sorry. We're doing number 2.
Number 2. Okay.
So it's 4.5 is the radius, right?
Mm.
Yeah.
Because it's half a 9, so the radius is 4.5. So that radius is really 4.5. Right? Okay. So now it's the same formula up here. 1/3 base times height. So the base, you can calculate what that base is. That base is equal to pi r squared, right? So 3.14. R squared is 4.5 times 4.5, right? That'll give you the area of the base. So whatever that is. Somebody want to tell me what that is? It's like it's 16, 20, 60 or so, somewhere around 60. I don't know exactly, but you know,
Times 4.5. Where? Shit.
between 50 and 70.
21.2.
No, it gotta be more than that. I want 4.5 times 4.5 times 3.14. Because that's the base, right?
No, that's what I got.
Well, it'd be 16. 4 times 4 is 16, so it's closer to 20. 4.5 times 4.5 is somewhere around 20. 20 times 3 is 60. So that's how I got my number.
Yeah, I got 21 something.
No, but you know, you got to multiply one more thing. It's 3.14. Don't forget pi.
No, I had it in there.
No, it's 63.58.
Oh, okay. Think about it.
Just say 63.6 or something.
63.58.
Yeah, there you go. Thank you. I'm just going to say that. And that's square centimeters. Okay, that would be the units of it, right? Oh, I can't make, okay, that's the units for that, okay. Then the last part is calculating the volume, and the volume we said is equal to base times height. So we have the base is 63.6, 63.6 times the height of 6, right? And what is that? 360, 370, somewhere around there.
Times
What do you get?
6.
I get 21.48.
What is it?
I get 21.48 because I use 63.58
Yeah, but it's 63 point, okay, times 6.
times
That's
6.
360 something, 370. What?
0.6 times 6.
Times 6.
381.
381.
Okay, we'll go with 381. Yeah, perfect. 381, and that's centimeter cubed, right? Okay. I did this one in 2 steps. I determined what the base, I could on this one here, I could have said the base is equal to 3 times 3, right?
Mhm.
Which is equal to 9. And then I could have plugged that into this. Oh, you know what we forgot to do in this? No, we didn't forget. No, that's different. I'm sorry. Yeah, the base would be 9 and then times 1/3 times 3, and you're still going to get 9 cubic feet. Anyway, but in this new one here, of this cone, the base is 63.6 times the height is 381. Okay, I think that's as much as we're doing as far as geometry goes today. Okay.
Mhm.
So let's take a 10-minute break and we'll get back together again. And we'll go over some of these problems that we didn't go over. Okay, so it's 9:37. Okay, and I'm going to stop recording.